Here we go, guys. Online quiz, trig identities. So there's a few properties that we got to know, some basic properties. So I'm going to put them here. I'm going to say basic properties. And I did cover them with B day, but not with A day. So my apologies. I'm covering them now with you guys. So here we go. So if it's an odd function, so an odd function is like sine of negative theta, and it's the same properties as when you were in algebra. So sine of negative theta is the same thing as negative sine theta. If it's an even property, like cosine theta or cosine negative theta, cosine's an even function. So cosine negative theta is the same thing as cosine theta. And of course, the reciprocals are the same. So the reciprocal of cosine is secant. So secant of negative theta is the same thing as secant of theta. And the same thing happens with odd. Sine is odd. What else is odd? Tan is odd. So tan of negative theta is equal to negative tan of theta. And that's just properties from even and odd, right? If it's odd, f of negative x is equal to negative f of x. See? Hopefully you remember that from your algebra days. If it's even, f of negative x is equal to f of x. We'll cover that in more detail as we get stronger with trig. Not bad, right? Nothing crazy? Let's see, what else? If you square it, so if I have something like this, sine squared of negative theta, in this case, if I'm squaring it, then that doesn't matter then. Because negative times a negative is going to be a positive. So if you have a negative argument, it's the same as you have a positive argument. Chab, I don't know what you're talking about. Okay. Side note again. Side note of your side note. Sine of negative pi over 6, if I call that squared, well, sine of negative pi over 6 is negative half. And then I square that, and look, I get 1/4. So now let's try sine of pi over 6. And I'm going to square this guy, see? So sine of pi over 6 is a half, and I square that. Oh, look, I get the same thing, 1/4. So that's what I mean. So sine of negative pi over 6 is negative 1/4 is half, negative half. And then when I square it, it turns to a positive 1/4. Yeah, see, hopefully you guys can see the unit circle is important. If you're weak on that, it's going to be kind of hard to keep going, right? So this is true for all, guys. So, Chop, what does that mean for all? Cosine of negative, well, cosine was even anyways, but it's even more true now. And then tan squared of negative theta is going to be tan squared of theta. And it's also true for the reciprocals of those. Yay or nay? Okay, what else? If the period, what's the period of sine and cosine? No, the period of the parent function, like y equals cosine x. The period is 2 pi, yeah. So theta plus 2 pi is the same thing as sine theta. So for all of them, if you see a plus 2 pi, it's the same thing as just saying sine of that angle. For all of them. Cosine theta plus 2 pi is the same thing as cosine theta. Tan of theta plus 2 pi is the same thing as tan theta for all. See? Now, tangent has a period of pi, so I probably should note, I'm going to put note, that tan of theta plus pi is the same thing as tan theta. Because tan has a period of pi. Same thing with cotangent. Let's see. Tan and cotangent, yes. Okay, I think we're good with all the side notes. I think we're ready to go. Okay, here we go. You guys ready? So I'm trying to add sine squared over cosine squared plus cosine theta. What do I got to do to cosine theta to add it? Common denominator. Multiply by cosine theta over cosine theta. That's just a 1. When I do that, you're going to get sine squared theta over cosine theta plus cosine squared theta over cosine theta. Now that you have cosines, like the denominator is cosine, I can write sine squared theta plus cosine squared theta over cosine theta. And now look, what is sine squared plus cosine squared? 1. So now I have 1 over cosine theta from the Valentine's formula. Oh, did you call it the love formula? Yeah, let's not call it that. Let's call it the Valentine's formula. I don't think Montelongo will. Well, I don't. Okay, love is love. I guess that's fine. All right, 1 over cosine. What's secant? Done. There it is. Oh, it looks like it's winking. Okay. All right, next question, number 2. Depending on what quiz you take, it's going to look like this. Maybe you'll see a pi over 2 minus x. It's just a property. Have we covered some of these properties? Well, kind of. We talked about even and odd, and hopefully you can make the connection. But if you can't, like let's say you're looking at it and you're like, I don't know. If you can't make that connection, just do this by brute force. Chav, what do you mean by brute force? Pick an x value. If x equals pi over 6, okay, if x equals pi, I'm going to write the word if. If x equals pi over 6, then Roman numeral number 1, cosine of pi over 6 is square root of 3 over 2. Hopefully you guys know that off the top of your head. And then remember, x is pi over 6, so that's what I made it. So the other one, cosine, that negative is this negative of pi over 6. Oh, that one is also square root of 3 over 2. That's the same as that. And let's see what it's saying. A and negative a. Nope. It should have just been a and a on both of them. Do you guys see how we did it? And then by brute force, again, I'm going to write, now I'm doing number 2. Sine of pi over 6 equals 1/2. And then sine of negative pi over 6 equals a negative 1/2. And that's in quadrant 4. And then I look, that says a and negative a. Oh, okay. Yeah, that one checked out. Roman numeral number 3. Tan of pi over 6 equals, let's see, y over x. 1/2 divided by square root of 3 over 2, which is 1 over square root of 3. And then I go tan of negative pi over 6, negative 1/2. You can already see it's the opposite, right? Over square root of 3 over 2, which is a negative 1 over square root of 3. And I'll slow down. I see one's positive, and I see one's negative, positive, negative. Oh, okay, that checks out again. This is by brute force, so 2 and 3 are correct. You could have also done it. So, Chop, how do you do it the right way? And I'll slow down. You could have also done it by looking, oh yeah, cosine is an even function. So from up here, oh look, I should have gotten cosine's an even function. So so that means it's symmetric on the y-axis. So no, this looks like that's a property of odd, so it's not. It's not. See, sine is an odd function, so sine x is a, sine negative x is negative a. Oh yeah, that's definition of odd. Okay, I hope that you see it, but if you don't, that's fine. Just by brute force. By brute force. Look, we did it by brute force. What's up? I picked it. I chose that. This is what you can plug in any value. I chose one. So whenever you hear me say by brute force, that means I'm forcing some x value. Okay. Third one. Okay, this is just like on delta. Whenever you see a fraction, and I'm not saying this is the best way, but this is the way that I think is easiest for you guys. Whenever you see a fraction, expand it. What's my habit? My habit is, that tan x, or that tan theta, I'm going to leave it alone, tan theta over 1, times, and then the secant in the bottom, 1 over secant theta. Do you guys see what we did? So anytime I see a fraction, I just expand it like that. What is tan? What over what? So I'm going to write sine over cosine. And then 1 over secant is the same thing as cosine. See, there it is. You can put a 1 if you want in the bottom. What's going to cancel out? So what do I have left? There it is. I think we're getting pretty good at that now. How do we feel? Let's look for that sine theta. There it is. Yay. Okay. All right. Question number 4. I see sine negative theta, and you're like, hey, Chop just told me that's an odd function. So if I have a negative theta, I can turn that theta into a positive if I put a negative on the outside. So I'm going to write negative sine theta. And then cosecant, just the reciprocal of what? I don't know. Sine, yeah. No, you're good. They at least started with an S, so you're good. Plus, and then both of these have positive arguments, so I don't have to mess around with anything. Cosine is cosine. Secant is 1 over cosine. Do you guys agree? All right, here we go. Notice these cancel out, but notice the negative in the front. So I'm going to say negative 1. And then again, these cosines cancel out again. And a plus 1. What's negative 1 plus 1? There you go. How do we feel? Okay. Question 5. It says 1 plus cotangent with a negative theta in it. Because I'm squaring it, I know that whatever I have, negative times a negative is going to be a. So you can just change that theta, negative theta, to a theta with a square on it. And then you just look at your notes. 1 plus cotangent squared is equivalent to? No. Cosecant squared. Say it again. Oh, I did this, miss. Right. Did I put it up here? I just use this property. See how it says all? So if I'm squaring it, you can just turn the negative into a positive. Because negative, well, yes, but I don't want you to be a robot. Do you know why? Okay. I'm going to pick an easy one. Side note, don't write this down, just listen. Tan squared of negative pi over 4. Do you know what tan, I'll just go ahead and put it here on the side. Tan of negative pi over 4 looks like this. Here's negative pi over 4. And remember that the x value is positive, but the y value is negative. So this is parenthesis, negative square root of 2 over 2 divided by square root of 2 over 2, close it squared. That's what it means. Negative 1 squared. What's negative times a negative? Positive 1, see? And if I were to say tan squared of pi over 4, well, that's just going to be 1 squared, and you just get 1. Look, positive 1, positive 1. So if I have a negative angle, I just turn it into a positive, and we're good. Cool or not cool? There it is. And then just choose cosecant squared. And there's my cosecant squared. Okay. Are we okay so far? All right. Here it is. Here's another one. Anytime I see a fraction, the first thing I'm going to do, I'm going to go cotangent squared theta over 1 times 1 over cosecant squared theta. Are we okay so far? Cotangent is what over what? Yeah. Make sure to put a square on it because it's squared. And then 1 over cosecant, if I bring it up, it turns into a... So make sure to put a square on it because it's squared. Yay or nay? What's going to cancel out? Bam, bam. What do I have left? There it is. Cosine squared. Oh, she got this one wrong. This is just a random one of you guys that I printed out. I think she did pretty good for her first attempt. All right, here we go to the next one, guys. What's 1 plus 10? Okay, so rewrite. I'm going to put the word rewrite. I don't want to see pi's in there. 1 plus 10 theta plus pi. Well, the period of 10 is pi. So this theta plus pi is the same thing as just saying 1 plus 10 theta. Yay or nay? And all of them, when you add 2 pi, you're going to be back in the same location. So this one's the same as 1 plus cotangent theta. If I were to see that answer somewhere, which I don't, but if I were to see that answer, I would have chosen that. So now, what am I going to do? I'm going to write it like this. 1 plus tan is sine over cosine over 1 plus cosine over sine. Write that. Now what I need is a common denominator in the numerator and a common denominator in the denominator, if that makes sense. So that 1, I'm going to turn it into cosine over cosine. Cosine over cosine is still 1. So here it is. And usually I don't show this step, but I'll show it this time. Cosine theta over cosine theta plus sine theta over cosine theta over what? Sine theta over sine theta plus cosine theta over sine theta. And I'll show it. I'll show you in case you guys are just going through the motions. This cosine over cosine is your 1. This sine over sine is a 1, but in the denominator. You guys see that? Yeah. If you had like a negative 1, yeah, negative sine theta over sine theta. Okay. So now that I have that, here we go. Here's what we have. Cosine theta plus sine theta over cosine theta. All this is over sine theta plus cosine theta over sine theta. Yes, miss? Yes. But I unplugged it earlier, so. Say it again. I'm gonna what? Yeah, of course. Yeah. Yeah, I didn't know what you were talking about. Yeah. All right. Keep, change, flip. Keep this guy, cosine theta plus sine theta over cosine theta, times, flip it, and or change, and then flip. Sine theta over sine theta plus cosine theta. Why do I keep, I guess I'm not pushing this hard enough. All right. If it helps, put parentheses around your binomial. Binomial just means two, right? Something that's adding something plus something. Yes. Heck yeah, cancel them out. Bam, bam. Now when I multiply this sucker, I get sine theta over, which is just tan. Yes.
Is it because it's a whole?
Yeah. A plus B is the same as B plus A. Right? 3 plus 4 is the same as 4 plus 3. So, boom, boom, 1. So, if I were to, I guess you can rewrite this the same. Like, it's like, you know what I mean?
Yeah.
They're the same. All right, next one. If you have issues with algebra, that's where your issues are going to start coming up. Notice there's a square here. So that's what I'm going to do first. I'm going to go sine theta plus cosine theta squared. Actually, I said I was going to do that first. So times sine theta plus cosine theta minus 2 sine theta cosine theta. We know that that's what it means, right? Okay. I'm going to show you guys this, but there is a way to be really fast. Sine times sine, sine squared. Sine times cosine is sine theta cosine theta, but I want you to realize that you're going to have two of them, so you should really be putting a 2 in the front. But I'm going to show you where it comes from, see? Plus cosine theta sine theta plus cosine squared theta minus 2 sine theta cosine theta. Okay. A times B is the same as B times A. So these two right here no, they don't cancel because there's a plus in the middle. Oh, yeah. You're talking about, that cancels out with the other one. Yes, you're getting ahead of me, though. These two right here, there's two of them. So I'm going to rewrite it as sine squared theta plus 2 sine theta cosine theta plus cosine squared theta minus 2 sine theta cosine theta. The 2 sine theta cosine theta and the negative 2 sine theta cosine theta, what happens to those two? They cancel each other out. Now I just have sine squared theta plus cosine squared theta. That's a 1. This person got it right. Yay. She was doing really good all the way until like question 10 or something. All right, question number 9. Which of the following is equivalent? So they're being nice. I think they're being nice to us. Look at this. As soon as you see anything squared with a 1, plus 1 or minus 1, it's probably a property. Yeah, that's a demerit. What is tan squared plus 1? Do you remember? Yeah, side note. Tan squared theta plus 1 equals secant squared theta. I think we've had it as 1 plus tan squared, but it's the same. So I'm going to rewrite this as 1 over secant squared theta. What's 1 divided by, if I have a secant squared theta on the bottom and I bring it up, what does it turn to? Cosine squared theta. There it is. So look for that. Is this helping, guys? Okay. All right. There are so many ways to do this one, guys. So many ways. You could factor out a sine squared, or you could distribute these two right here. Let's see, what would I do if I were just learning this? Okay, I think if I were a rookie, like brand new rookie like you guys are, I think my first thing would have been like, oh, let me just multiply these because they're being multiplied. I think that would be my first thing if I were a rookie. So I'm going to go sine squared theta times cosecant squared is the same thing as what? Perfect. So I just want everything in terms of sine and cosine. And then here's what I notice. What happens with my product right here? Sine squared over 1 times 1 over, they cancel out. And now look what you have. 1 minus sine squared theta. And hopefully there's red flags coming out. Well, not red flags, green flags. And 1 minus sine squared is the same thing as, there you go. And I'll put a side note over here. Side note, cosine squared theta plus sine squared theta equals 1. So if you move the sine squared to the right, cosine squared theta equals 1 minus sine squared theta. And that's exactly what we did there. All right, let's go to the next one. Let's see. Okay. The programming looks a little off. It looks a little funny. This is not part of the numerator. This actually, let me rewrite it. It looks like, it's supposed to look like this. But I think maybe the software that UH has or who knows, like something messed up with their little programming. Maybe it looks like that in your computer, but hopefully it doesn't look, this is a screen capture, right? Or this is a PDF. So hopefully that +1 looks more like +1 like that. It looks like this. Okay. Notice that the fraction ends here. So that +1 is to the side like that. Cool? All right. I think they're being nice to us. I don't know. Maybe not. Maybe they are. Maybe. You see that 1? I would have turned that 1 into 1 plus tan squared over 1 plus tan squared. Turn this into 1 plus tan squared over 1 plus tan squared. So here's what I now have. I'm going to write it as 1 minus tan squared theta over 1 plus tan squared. I guess I'll do it in 2 steps. Plus 1 plus tan squared over 1 plus tan squared. Now that I have it all, I'm going to write it 1 minus tan squared theta. And that's a plus symbol. If it would have been a minus, distribute it. Plus 1 plus tan squared theta over 1 plus tan squared theta. What is going to zero out in the numerator? The tan squares. Bam! Bam! What's 1 plus 1? So I have 2. I'm going to put equal sign. 2 over 1 plus tan squared. We just talked a little bit ago about what 1 plus tan squared was. Yeah, what is it? It starts with an S. Secant squared. 2 over secant squared theta. I don't see that 2 over secant squared theta, but I know the secant squared is in the bottom, so if I bring it up, it's going to turn to a... So 2 cosine squared theta. Is that in there? There it is. Cool or not cool? Last one. There are many ways to do this one, but I'm going to show you. Let me see. Yeah, okay. I'm going to do the way that I think you guys would do it because you guys are rookies, right? Once you get more experience, I'll talk to you about the other way. So you guys being rookies, I think you would look at this and you would say, well, I have 2 fractions, and the only way to add 2 fractions is if I have a what? So I think that's the route you guys would take. So I'm going to multiply the one on the right by 1 plus cosine theta over 1 plus cosine theta. And then the one on the left by sine theta over sine theta. Once you get more experience, you're probably not going to go that route. You're probably going to do like a difference of squares for one of them and then cancel out and all that good stuff. What's up? No, what do you mean? Because there's a plus in the middle. I'm not multiplying. Oh, yeah, you're doing an advanced technique because you learned about, did you do series or did someone teach you that? No? A over B plus C over D is the same thing as AD over, yeah. You learned, I'm not going to do any tricks. If you know a trick, go ahead and do it. Have you talked about, did you ever do circuits, series circuits or parallel circuits? Because I think that's what you're talking about. No? R1, R2, 1 over R1.
The interruption. This is just a reminder today that we do have an adjusted lunch schedule, so please check your amended schedules. Both middle and high school will all be reporting to lunch at the same time. High school, you will be in the cafeteria, and middle school, you will be in the auditorium. Once again, All students will report to lunch at the same time. Please make sure that you report directly to the cafeteria when we release after this period. Thank y'all and have a wonderful Cardinal Day.
All right, guys. So there it is. All I did was just multiply. I'm not distributing the denominator. That's for a reason. You'll see right now. So I'm going to write sine squared theta plus, and here's my, it's not a big hack. I'm just going to expand this. Notice that's I have a square there. So that's 1 plus cosine times 1 plus cosine. What's 1 times 1? 1. 1 times cosine is cosine, but how many of those are you going to have? So I'm going to write plus 2 cosine theta, and then cosine times cosine. There it is. All over sine theta, parenthesis 1 plus cosine theta. All right, then here's what I'm noticing. All right, I'll wait. Here's what I'm noticing. I see a sine squared and I see a cosine squared, and together those are 1. So I'm going to rewrite it. And what's 1 plus 1? So I'm just going to skip one step. So I'm just going to write 2 plus 2 cosine theta. Are you guys okay with that? Over sine theta, parenthesis 1 plus cosine theta. And we're so close. Green flag should be going up, should be firing. I see a 2 plus 2 cosine theta, so that means I can factor out a, so I'm going to put 2 parenthesis 1 plus cosine theta over sine theta, parenthesis 1 plus cosine theta. Now, because I have a 1 plus cosine term in the top and a 1 plus cosine term, and I know there's like 2 terms, right? But like the 1 plus cosine in parentheses, I have one in the top, one in the bottom. What can I do with those 2? Cancel them out. Bam. I wanted to choose a different color. Bam. Bam. Now that I cancel them out, I have 2 over sine theta. I don't see that answer like that, but I do see it. When I bring that up, what do I get? Is that answer there? Did going over this help? Okay, do you think we can get 100 now? All right, when does it due? All right, take care of business, guys, and I hope you guys are happy. I'm just going to stop it.